Hi all, good morning. This is Kavin from Cognizant. So I'm going to walk through my presentation on AWS Chaos Engineering Framework. So let me go ahead and share my screen. Okay, hope my screen is visible. Can someone confirm in the chat? Okay. Okay. So AWS Chaos Engineering Framework. So this presentation is all about how to do chaos testing in AWS. Um, Got it. Okay. So how to do chaos testing in AWS? So chaos testing being introduced by Netflix and Amazon a couple of years ago has been a recent trend in non-functional testing, and many of us have started looking into the importance of bringing resilience into cloud. So initially, before an year or before 2 years, we can say, so most of the resilience testing involved just a failure of the existing nodes or parts and just restarting them to see how it impacts the performance or something. But now chaos engineering has been advanced such that they are seeing every levels of failures, such as causing the resource exhaustion, causing the CPU drainage, causing the memory utilization to 100 percentage, or even causing network delays. So that's how chaos engineering has been deeply started integrating with every part of non-functional testing. So now there are commercial tools like Gremlin and a few other tools which can help us to easily inject chaos into our systems. Whereas, considering the cost of Gremlin, which is almost twice the cost of the most popular commercial load testing tool, LoadRunner, so most of the times, instead of injecting deep chaos into the system and having deep resiliency test, we are in a situation to do manual resilience testing, such as the failover testing. So, considering the fact, it's like we are proposing a chaos engineering framework that is completely free of cost, that is built using AWS System Manager. So AWS System Manager is one another AWS component that allows to execute commands and other batch operations into the EC2 instances. So using this ability of EC2 instances, we are going to inject custom Linux commands into the EC2 instances that will cause CPU drainage or any other resource starvation. So coming to the framework proposed, so this is the framework which we are proposing for this chaos engineering in AWS. So it uses the AWS System Manager as its primary component. So Linux has some components called stress ng and traffic control, which allows to cause CPU, memory, IO, and disk level of failures. And the traffic control component allows to inject network latency, packet loss, and packet corruption, those kind of scenarios. And AWS has a lot of API functions to control their resources. And using AWS API functions, we are using them to inject system state level failures like restarting an instance, stopping instance, and terminating instance. So utilizing these three components, so this framework is built. So so what happens here is the AWS System Manager allows us to create test scenarios in either JSON format or YAML format. When you go and create a new document in AWS System Manager component, it will by default it will show you a JSON and YAML template. So that template we'll be seeing in the upcoming slides is this scenario file which defines what needs to be executed on the EC2 instance. So we are going to use those documents to run custom Linux commands of the stress ng and traffic control components, which will automatically cause those resource level failures and network level failures in those particular EC2 instances. So the command output, the stress scenario output can also be written to Amazon S3 buckets, and also they can be stored as CloudWatch events. Coming to the framework process level, it is the setup is very much easier. We just need to create an IAM role which has the access to execute the system manager commands. So after creating an IAM role, we need to validate whether the instances have this SSM agent installed. So these SSM agents allow AWS System Manager to communicate with the EC2 instances. By default, all the Linux-based operating systems, Linux-based operating system AMIs, they are having this SSM agent. So this step can be skipped for that. And the third step would be the installing stress NG and traffic control Linux components in the uh, EC2 instances AMI. So this is a one-step process. So once this is installed in the auto-scaling AMIs, then whenever a new instance spin up, automatically these dependencies will be installed. And the fourth step would be configuring the AWS things like S3 buckets and CloudWatch logs, into which we need to write our test scenario output. And the fifth step would be the creation of test scenarios, which I said is the system manager documents. Each document is a test scenario file, and it allows us to create our failures in resource level and state level. And the final step would be the execution. So coming to the document types, there are two types of documents. One is the run command documents, and second one is the automation documents. The run command documents allows to execute Linux commands, whereas the automation documents allows to execute AWS API actions. So using the Linux commands, that is coming under the component stress engine traffic control, which can be simply installed in Linux using sudo yum install stress engine and traffic control. It allows to cause resource exhaustion like CPU, memory, disk, IO, network, everything. So I'm just telling this in a high level, but there are multiple scenarios which can be created under these five categories. I'll be showing that in the next slides. So coming to the scenario design. So for creating the scenarios, we need to go to the AWS System Manager, and in the left pan we can see a column section called Documents. In the Documents, we can create a new document from where we can write a custom coding for executing this CAVOs. So if you can see the screen, so this is a simple YAML file which allows to cause a CPU stress in an incremental way on one of the EC2 instance. So if you can see the section of the code, um, so um, the, see the parameter section. So the parameter section is nothing but the input parameter section, in which we will be giving the inputs for the failure injection, which could be the um, duration of the attack, the intensity of the attack, and how many CPUs I am targeting in case of a CPU attack. So these things we need to define the parameters column, and in the main step column, I'm executing the AWS API for running a shell script. And inside that, I'm giving the run command, which is again a simple Linux command for executing this stressng command. So it would be stressng hyphen c hyphen l hyphen t. So which means the stressng component would be invoked for number of cores, and the level would be the input which I'm giving for the intensity of CPU attack, and for the particular amount of duration the attack would be injected into the particular EC2 instance. And I can also give some sleep API functions, so that after giving a brief pacing of some time, then I can increment the CPU to a new level, and in that way I can build a incremental CPU attack on particular EC2 instance. So in the same way, we can define scenarios for memory stress, IO stress, disk stress, and all, and we can also have combination of all these stress together. So these scenarios can be executed against a single EC2 instance and also multiple EC2 instances, thus allowing us to create extensive chaos over the EC2 instances. Uh, uh, like enabling us to understand how much the system is resilient when everything fails. Coming to the scenario design of automation documents, so as I said, this automation documents uses AWS APIs like describe instances, reboot instances, terminate instances. So using these AWS APIs, we would be getting the list of instances, and we'll automatically rebooting the instances, and we'll be like, I mean, we can also terminate the instances. Those kind of things we can do inside this module. So if you quickly see the coding part here, so it would be like the same thing, like in the parameters here. For restarting multiple instances, I need the availability zone and the tag name to filter out the instances. So those things are defined as parameters, and in the main steps I am executing AWS API functions for getting the list of instances in the particular zone and rebooting the instances in that zone. And after that, I'm also adding a session to check whether all the instances have been successfully rebooted. So this is about the scenario design part. Now coming to the execution part. So if we in the so now after creating in the AWS System Manager component, all my command documents will be there. If we go and execute the document, it will bring up this window in which it would give us the input fields for all the things which we defined in the parameters. Say we have defined a duration, a level, and CPU here. So those things will be populated here. So the scenarios would be executed based on the input values which I give against the targets which I am selecting below. So I can select single target, multiple target, and also multiple instances in multiple zones. Coming to the automation documents, it works the same. And instead of input parameters for giving the CPU, memory, and other kind of metrics, I'm going to give the availability zone in which it would reboot or terminate all the instances or particular instances which I'm going to give as a part of this input parameters. So the scenarios after they are executed, they can be monitored in the AWS System Manager as well. It will show the step-by-step execution and will show what is the output which I have given as a part of the Linux command, and also it would show whether each step is successful or not. So, so as you can see, the entire framework it works in a similar way compared to a load testing process. So this system operates in a way such that we would be kickstarting the load test, and in the middle of the load test, we would be injecting this kind of chaos into the AWS, and we would be observing the system performance, reliability, and failures on errors, and see how these chaos impact our system, and if they impact, what is the time it takes to recover for spinning a new instance, and any other failover mechanisms implemented. So coming to the best practices, so this chaos testing can be started with the minimal of having blast radius in any one of these C2 instance, and it can be extended to all the instances in the region to understand how strongly our system are resilient. And instead of like manually giving the instances, we can group the instances based on resource groups. Say the EC2 instances having a functionality of a particular microservices can be grouped over into separate resource groups, and for other APIs can be grouped into resource groups, and the chaos can be introduced into each of the resource groups in separate test. And the advantage of this framework is this can be easily integrated into Jenkins pipeline, because all these AWS System Manager documents, they can be executed in from AWS CLI through CLI commands, and those CLI commands can be added to a Jenkins pipeline job, so that after every performance test execution or during the performance test execution, these jobs can also be automatically run in parallel. And it's also recommended to run these jobs during night times with a huge blast radius, which means across all the instances. Even though if it brings any downtime, it won't be much issue, and we can understand the system behavior. And at the last, configuring the SNS notifications and S3 buckets allows us to get frequently notified about any chaos, and we can take any preventive actions. So like this is like this idea is inspired from the AWS System Manager functionality as proposed by Amazon, and we normally use this test engine traffic control commands manually to inject chaos, and utilizing the functionality of System Manager to execute the Linux commands, we are implementing this framework. um, so that's it about this framework. Any questions and answers are welcome. I'm done with the presentation. Any questions or any feedback on this framework? Um, I got a question. Do you have a blog or some document we can refer to start with this? I don't have a blog, but I have documented this as a case study, and most of the things are shared in this presentation. If you want to have a look at the blog, then I think one of the reference material contains a high-level conceptual diagram of how to implement this. Maybe by looking into that, we can understand. But still, if you can share this PPT or something, then it would be very easy to start with. What are the customer use cases for this framework? Is this framework available for end users to learn and deploy in production environment? Okay, so the customer use cases for this framework is just to inject high level chaos into the system, not basic failover mechanisms like restarting an instance or stopping or disconnecting a database. Instead, it allows different use cases like causing everything to fail in a system, like all the resources, network. The use case is to cause real-time failures into the system, and this framework allows to is more beneficial when implemented in production environment too, because that's how Netflix and Amazon thrives, and they understand the real-time impact, and that's how they fix them. Hope this answers. Mm, Thank you. I think it's time. I'll end my session. Thanks all. Bye.